Hello everyone. In this video, let's solve some problems based on Fourier series. See this problem. Obtain the Fourier series expansion for the function f of x is equal to pi minus x by 2 the whole square. See the interval 0 to 2 pi. It is a open interval. If it's a closed interval, I'll get less than or equal to on both sides. So whenever you see that hence deduce, then immediately you have to check which are the points included. So here the points between 0 and 2 pi are there in this interval, and 0 and 2 pi is not included. When we will include it? If there is a less than or equal to symbol. And hence deduce that this is the first one is pi square by 6, second one is pi square by 12. So pi square by 6 is equal to 1 by 1 square plus 1 by 2 square plus 1 by 3 square and etc. Pi square by 12 is 1 by 1 square minus 1 by 2 square plus 1 by 3 square etc. And the next one is pi square by 8. So pi square by 8 is 1 by 1 square plus 1 by 3 square plus 1 by 5 square. We have to prove it. So hence deduce means first we have to express f of x in terms of Fourier series, and then we have to substitute suitable values in the interval. Here the interval is 0 to 2 pi. Between that we have to substitute some suitable values to get these desired results. Now first thing is we have to check whether the function is even or odd, because we saw in the last video if the function is even, no need to calculate bn value. Same way, if the function is odd, no need to calculate a0 and an. It saves our time and there will be a mild difference in the formula when we are writing the interval. So as I told you, we can solve it graphically for checking even or odd, or we can prove it mathematically. So first we will try to prove it mathematically. That is, wherever x is there, you are going to replace 2 pi minus x. If the interval is minus pi to pi, what we will do, wherever x is there, we will replace it by minus x. Here the interval is 0 to 2 pi, so we are replacing x by 2 pi minus x. This is the checking procedure. So wherever x is there, I am going to replace 2 pi minus x. Pi minus, in the place of x I have replaced 2 pi minus x by 2. And then pi minus 2 pi is minus pi. This minus and minus will become plus. So minus pi plus x by 2 the whole square. Now I have to check whether this is equal to, it should be either equal to pi minus x by 2 the whole square or minus pi minus x by 2 the whole square. These are only two possibilities. I am taking the negative sign outside. If I take the negative sign outside, what I will get? Pi minus x the whole square. The negative sign, when it goes outside from the square, this will become positive. So this is nothing but pi minus x by 2 the whole square. If you have a doubt, we expand this and expand this also, you will get the same answer. That is, if I expand this, what I will get? Minus pi square plus x square minus 2 pi x by 2. Sorry, 2 square is 4. Correct? So I am going to expand this. Expand the second one. So this is minus pi the whole square. So it will become, I will simplify this, pi square plus x square minus 2 pi x divided by 4. If you expand this, what you will get? Pi square plus x square minus 2 pi x divided by 4. Same thing. So it means the function is even function. What is the advantage if the function is even? Then bn will become 0. So f of x will become a0 by 2 plus summation n is equal to 1 to infinity an cos nx. There is no the sine term. That is, what is the next term? Summation n is equal to 1 to infinity bn sin nx. Since bn is 0, we can write it directly. So I have proved mathematically that this function is an even function in the interval 0 to 2 pi. So again I repeat, if it's minus pi to pi, you will replace x by minus x. Here the interval is 0 to 2 pi, so I am replacing it by 2 pi minus x. Okay. So what we have to do? First find a0. If it's a normal formula, what I will write? 1 by pi, 0 to 2 pi I will write. Since I have proved that the function is even, only I have to find it only 1/2. So 0 to 2 pi, I will find it and multiply it by 2. So 2 by pi integral 0 to pi f of x dx. So what is f of x? Pi minus x by 2 the whole square dx. If you want, you can substitute pi minus x by 2 as u. Okay, here I have taken 2 square outside, that is 2 by pi into 1 by 4, 0 to pi, pi minus x the whole square dx. So what is the integration of this? That is integral ax plus b the whole power n dx is ax plus b power n plus 1 by n plus 1 into 1 by a, this x coefficient. We'll write it. Again I repeat, if you are getting confused, you can replace pi minus x by u, and then when you are changing u, you have to change the limits also. Integration by substitution, or you can use this formula directly. So if I use this, pi minus x power 2 plus 1 by 2 plus 1, that is pi minus x power 3 by 3 into coefficient of x. What is coefficient of x? Minus 1. So 1 by minus 1. Here we have 1 by a, right? So 1 by minus 1 we have written. Now we have to simplify this. This minus I have taken outside, 3 also taken outside, minus 1 by 6 pi, pi minus x the whole cube, and we have to apply the limit 0 and pi. First we will apply upper limit minus lower limit. When we apply upper limit, what will happen? Pi minus pi the whole cube. Pi minus pi is 0. So upper limit is 0. Minus lower limit. Lower limit is 0, right? Pi minus 0 the whole cube, which is nothing but pi cube. By simplifying, I am getting pi square by 6 as a naught. Now what is the formula for an? 2 by pi integral 0 to pi f of x cos nx dx. In case if I didn't check whether it's even or odd, what I'll write? 1 by pi integral 0 to 2 pi. Since I have checked, I am writing it only for 1/2. So 2 by pi integral 0 to pi f of x cos nx dx. And f of x is pi minus x by 2 the whole square. The 2 square I have taken it outside. So what we have? Pi minus x the whole square cos nx dx. So again 2 terms in multiplication. Then what we will do? Bernoulli's. The term that's going to vanish in few differentiation, that term is going to be u. So this term I will differentiate and this term I will integrate. Same Bernoulli. Then we will apply the limit. So we are going to use the Bernoulli rule. The constant 1 by 2 pi is outside. First we will write the term that I am going to differentiate. We won't differentiate in the beginning. Remember? So first we are going to write the term pi minus x the whole square. And what about the sign? Plus, minus, plus, minus. It will be keep on going. So I have written pi minus x the whole square. What is the differentiation of this? Come here. 2 into pi minus x. Minus x differentiation is minus 1. Function of a function. First sign is plus, second sign is minus. First we will see only the differentiation. What is the third sign? Plus. And this 2 is going to be there as it is. Pi differentiation is 0. Minus x differentiation is minus 1. Okay. So already this minus sign is there. We are not taking this minus over here. Okay. This sign is plus. We have written 2 as it is. Minus x differentiation is minus 1. And we have this minus 1, right? That minus sign I have written it in the beginning. Since it's in multiplication. 2 into minus 1. So minus 2. This minus I am not carrying. This is just in the formula. This we should not carry for the next term. So I have written plus. So what is that? Plus, minus, plus. Pi minus x the whole square. Forget about it. Just write down the differentiation of pi minus x the whole square. Forget about the sign. Just take the next value. Here it is plus only. This 2 and this minus 1 I have written minus 2 and minus x differentiation minus 1. The second term what we are going to do? We are going to integrate. So what was the second term over there? Cos nx was there. Cos nx if I integrate sin nx by n. Sin nx if I integrate minus cos nx by n. Already one n is there. So it will become n square. Cos integration again sin nx by n. N square is there. N square into n will become n cube. And this minus n I have written as it is. That's it. So now we are going to apply the limit 0 to pi. So when we apply the limit, what is the upper limit? One second. No, you can see. Yeah. What is the upper limit? Pi. What is the lower limit? 0. So sin n pi is going to be 0 and sin 0 is also going to be 0. So which are the terms will become 0? The first term will become 0 completely. No need to even apply the limit. Last term is going to become 0 because sin nx. So happily we are leaving these two terms and we are going to apply limit only for this second term. So I have written it again. Since we don't have the first and last term, only we are going to apply the limit for this term, which is the second term. So if I apply the limit, minus 2 by n square, take that common constant outside. So minus 2 by 2 n square, outside 1 pi is there. And what is there left over inside? Pi minus x cos n pi. Then it's easy for you to apply the limit. So this 2 and 2 will get cancelled. Minus 1 by n square pi we will have. And then if I apply the upper limit, pi minus pi 0. So first term will become completely 0 minus second term 0. Pi minus 0 is pi. Cos 0 is 1. So 0 minus pi. This minus sign and this minus sign will become plus. This pi in the numerator and the denominator will get cancelled and we will get 1 by n square. So your function is f of x is equal to a naught by 2. Don't write a naught as it is, because we have got a naught as, let me check and tell you. Yeah, it was there in the previous page. We have got a naught as pi square by 6. So a naught by 2. So we have written pi square by 12. So the moment you get a naught, immediately you write a naught by 2 and put it in a box so that you won't get confused. And then plus summation n is equal to 1 to infinity a n, what we have got? 1 by n square cos nx. And there is no bn. The problem is over. Okay. Now what we have to do? Deduce that. In the last problem also I told you, to get the particular result we have to substitute the particular value. Correct? So here if I have to substitute function value as 0, I cannot do it because they have given a open interval. Right? But still I want to substitute that value. Clearly I have mentioned open interval means 0 less than x less than 2 pi. That is open interval 0 comma 2 pi. It means 0 is not a point in the interval. But still I want to find f of 0. Then what we should do? This is the formula. That is f of 0 is the beginning of the interval plus end of the interval by 2. C plus 2 pi is nothing but beginning and end of the interval. What is the beginning of the interval? 0. F of 0. What is the end of the interval? 2 pi. F of 2 pi divided by 2. So this will give you f of 0. Why we are writing it? Because the function, the point 0 is not included in the function directly. In the previous problem what we did? Directly we have substituted 0 in the function. Here I cannot substitute. What is my function? F of x is equal to pi minus x by 2 the whole square. This is my function. Directly I cannot substitute x as 0 in this, because the point 0 is not included in the interval. Still we want to find f of 0. So in that case we have to do this. So f of 0 plus f of 2 pi by 2. So first we have to substitute f of 0. So if I substitute f of 0, what I will get? Pi minus 0 by 2 the whole square. So pi by 2 the whole square, that is pi square by 4. First value plus f of 2 pi. I am going to substitute 2 pi. Pi minus 2 pi. Pi minus 2 pi is minus pi. Correct? Minus pi by 2 the whole square. Minus pi also if I square it will become plus pi square by 4. So if you simplify this, 2 pi square by 8 along with this value, which is nothing but pi square by 4. So if x is equal to 0, then the corresponding value f of 0 is pi square by 4. And we are using this formula. Please note this formula. These are the small formulas, like if we want to find the end value, what we have to do. If we have to find the value at the point of discontinuity, again that will come in the next problem. So mark all these formulas. So we got f of 0. And the same thing it has mentioned. We cannot put x is equal to 0 directly because the given question has an open interval and 0 is not included in the interval. So right hand side if I put x as 0 in the solution, f of x we got right, a naught by 2, that is pi square by 12 plus summation n is equal to 1 to infinity, a n is 1 by n square cos nx, cos 0x. So this is nothing but 1. So pi square by 12 plus summation is equal to 1 to infinity, 1 by n square. If I take it to the other side and take LCM, how we will take LCM? Numerator and denominator, you multiply by 3. So you will get a common denominator. 3 pi square minus pi square. So you will get 2 pi square. And 4 and 12 LCM. So we will get 12. And right hand side is 1 by 1 n square, right? If I substitute n is equal to 1, 1 by 1 square plus 1 by 2 square plus 1 by 3 square. Summation means plus. So we got this desired result, pi square by 6. This is what they have asked in the first deduce part. Now we have one more thing to deduce. So for that, the interval is 0, 2 pi. So I have still I got the value at 0. Pi is pending. If I substitute x as pi, what will happen? Here pi is directly included in the interval. So directly you can substitute in f of, you can find and substitute x as pi and you can find f of pi. Yeah. If you see here, this side we got 0. Why? Because your function is pi minus x by 2 the whole square. If I substitute x as pi, what I will get? Pi minus pi by 2 the whole square. So that's why we have written 0. Right hand side, pi square by 12 plus summation is equal to 1 to infinity. an is 1 by n square. Cos nx, in the place of x we are replacing pi. This is the particular case, cos n pi. What is cos n pi value? Minus 1 power n. That's it. Simple. Take this pi square by 12 to the other side. We will get a negative sign. And here when you expand it, we are getting alternate sign, if you see. For the first one, put n is equal to 1, we will get a negative sign. Second one positive, because minus 1 power 2. Third term negative, fourth term positive. But the left hand side minus is there, no? Push it to the right hand side. So it will become first term positive, second term negative, third term positive. It will come reverse. So we got pi square by 12, second. So in this second deducer part, directly we have replaced x as pi. Can you guess what can we do for the third deduction? Got it? We'll be thinking for some other point, say x as pi by 2. And if we substitute in that, then what we will get? Cos n pi by 2. And we won't get the desired result. We will get some other value. It's like instead of pi square by 6 or pi square by 8, we will get some other value. But they have asked 3 things to deduce. So we should deduce to only those 3 values. So simple. Sometimes when you add 2 results or subtract 2 results, you will get the desired result. So if I add first result, what we have got? That is pi square by 6. Correct? Second result, pi square by 12. Why I have decided to add means, because in the final answer, if you see, only positive terms are there and only odd terms are there. So that is why we got the idea. First one, even terms are positive. Second one, even terms are negative. So if I add, these two will get cancelled. Very simple. So pi square by 6 plus pi square by 12, take LCM and simplify it here. Here 1 by 1 square plus 1 by 1 square. So 2 by 1 square. 1 by 2 square minus 1 by 2 square will get cancelled. This term and this term. 1 by 3 square plus 1 by 3 square. So it's 2 by 3 square. Take all the 2 common and take it to the other side. If you simplify, you will get pi square by 8. This is the deduce that part. So what we have learned today. In the previous class, we checked even or odd for minus pi to pi. Here, checking even or odd procedure in 0, 2 pi we have learnt. Replace x by 2 pi minus x. If you get the same function, then it's an even function. If you get negative of that function, that is an odd function. Okay. So here the interval is new, 0, 2 pi. And the second thing is deduce that part. If the point is not included in the interval, here that is 0. But still I want to know what is the function value. What is the formula? Beginning of the interval plus end of the interval by 2. This is the second formula that we have learned. Something new. And the third idea is, so always no need to think what value I have to substitute to get it. So simply even if you add or subtract the terms, we can get the desired result. For this we have to see this. By seeing this, we will get some idea. Okay. So coming to the next problem, I'm not going to solve it completely. I'll just explain and leave it to you. I want you to solve it. See this? Obtain the Fourier series expansion for the function f of x is equal to pi minus x by 2 in 0, 2 pi, and hence deduce pi by 4. Deduce that part is there. Immediately what you have to notice, I have to substitute some value in the interval, given interval, to get the desired result. Correct? So let's see about it later. First we will find the Fourier series expansion. And first what we are going to check? Even or odd. For that what we have to check? See the interval 0, 2 pi. So what we have to do? Replace x by 2 pi minus x. If it's minus pi to pi, what we'll do? Replace x by minus x. Correct? Since it's 0 to 2 pi, wherever x is there, you're going to replace 2 pi minus x. So pi minus, within bracket, 2 pi minus x by 2. That's equal to pi minus 2 pi, you'll get minus pi plus x by 2. If I take minus outside, I'm getting the same function, pi minus x by 2. So f of 2 pi minus x is negative of f of x. So the function is an odd function in this interval 0, 2 pi. What is the happy news if the function is an odd function? A0 is 0, an is 0, only you have to find bn. So since a0 and an 0, how your formula will be? F of x is equal to, one second, yes, now you can see, f of x is equal to a0 by 2 plus summation n is equal to, this is a general formula, a0 by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. Write this general formula. You have proved this as an odd function. So your a0 and an will become 0. Directly your function is summation n is equal to 1 to infinity bn sin nx. What is the value of bn? Formula 2 by pi integral, only 1/2 you are going to find, 0 to pi f of x sin nx dx. Just you are going to substitute, use Bernoulli, and very simple, you will get bn, and you have to substitute some suitable value to deduce this part. In case if you didn't check whether it's an even or odd function, how the formula will be? Yes, the formula will be like this. It's too big, right? F of x is equal to, you'll write all the three terms. You'll write a0 is equal to 1 by pi integral 0 to 2 pi f of x dx. An is 1 by pi integral 0 to 2 pi f of x cos nx dx. You'll do all the problem, completely all the integration. Finally, you will get a0 and an is 0 in this case. What is the difference in the formula? If I check, it is 2 by pi integral 0 to pi. We are finding it for 1/2. Please keep this in mind. In the formula, the integration you have to keep it properly in mind. And bn is 1 by pi integral 0 to 2 pi f of x sin nx dx. This is what you have to do if you don't know whether the function is even or odd, or if the function turns to be neither even nor odd. There are some cases where the function is neither even nor odd. We will discuss in the next class. So, better to check whether the function is even or odd to reduce our calculation. Since we calculated and proved that the function is an odd function, first term a0 also 0, second term an also 0. What happened to the third term? The formula slightly will change. Bn is 2 by pi integral 0 to pi we will write. Instead of 0 to 2 pi, we will write 2 by pi integral 0 to pi f of x sin nx dx. Since I told you to solve it on your own, this is very simple, Bernoulli, and you'll get only one term, and you'll get the answer bn as 1 by n. Okay, try to solve it on your own and try to get this. This is simple integration. And once you got 1 by n, sometimes you will substitute x as 0, you will get a different series, and you will substitute x as, since the interval is 0 to 2 pi, then you will try pi also, but to get the desired result, what they have given? Pi by 4, right? So you have to substitute x as pi by 2. Then you will ask this doubt, how do we know that we have to substitute x as pi by 2? So first you check on f of x part, simple. Okay. In the given answer, just check f of pi by 2. What is my question? Pi minus x by 2. Pi minus pi by 2 by 2. You will get pi by 4. In your answer, what you want? Pi by 4 only. Then you will come to know that, okay, I have to substitute x as pi by 2 to get the desired result. So, just we have to substitute these values. We got pi by 4. And then in our solution, we got bn as 1 by n, right? Just substitute. We will get sin pi by 2, sin 2 pi by 2. So, this 2 and 2 will get cancelled, sin pi. So, all the even terms, this 2 will get cancelled, it will become 0. You will be left only with odd terms. And the signs are alternate, so we will get plus minus plus minus. So, hence proved. I didn't explain this integration part because it's very simple and similar to the previous one. So, I want you to solve this problem on your own. Thank you.